Hello and welcome back to the channel, and in today's episode I'm going to show you how to create a snake game using Godot engine. We're going to try and recreate the classic look of a snake game. One interesting thing that you might notice that we're going to add is if we're going to hit the wall, we're not going to end the game. Instead, we're going to make our snake go along the wall in the direction um, that will be determined by the point on which the snakehead's gonna hit the wall. So yeah, let's get right into that one. So we can start our journey by going to godotengine.org and downloading the latest version of Godot. Be sure to download the version that is above 4, so in this case that's going to be 4.02, because the previous version is rather old and there are big differences between the version when it comes to language and how the engine itself works. So go to download section and just download Godot. I'm gonna only download Godot engine without the .NET. You can use different languages when it comes to Godot engine. If you love C#, like I do, you can write your games using C#, but we're gonna be using inbuilt editor and GTScript language to write our games, and that's what I'm gonna stick with, at least for now. You can always go to Godot community to check information about Q&A, upcoming events, tutorials, Reddit, GitHub. I encourage you to join their Discord where you can ask your questions. Also, you can go to Learn to check the documentation if you'd like to, but I'm gonna make it as user-friendly as possible. Of course, if you have some spare coins, always donate. Because this is open source, the creators are being sponsored by the community, which is great. And the engine itself is very simple. It's not so bloated as Unity or Unreal. And for learning programming or making simple games, I find it way better than Unity, but that's at least my take. One thing that is for me missing for now is the asset store, because for now, as you can see, this is looking rather pale compared to Unity, Unity asset store. So yeah, if you compare these two, you can clearly see the difference. But I hope that with time, the Godot asset library is gonna grow and gonna only get better. So yeah, if you go to download and download it, you're gonna download the zip. So go here and of course extract all, and then move it to location that you find convenient. This is the whole engine, right? No need to install everything else. If I'm going to click it, it's just gonna, as you can see, probably it's just gonna run, right? So really nothing fancy here. Okay, so if you have that downloaded, just gonna run it on my computer now. What you're gonna need to do is to start new project, and I'm gonna do just that. I'm gonna name this snake tutorial. Find a proper path where you'd like to keep all of your Godot projects. What I did is that I created game dev folder and then Godot folder, and here I'm going to keep everything related to Godot. So I'm gonna just create new folder for it. Oops. Got snake tutorial and say select current folder. Renderer forward is fine. Version control metadata git is fine if you'd like to use some version control. And version control for Godot is way simpler than in Unity, because in case of Unity, to basically make it run properly, you will have to use plastic SCM, which is their own solution and it's paid. In case of Godot, everything works pretty much correctly by just using good old Git. So let's hit create and edit. And what you should get is the view of our engine. And let's discuss this quickly. Here you can see the standard toolbar. One part that is interesting for us is, of course, the possibility to switch from 2D to 3D. And in case of Unity, you have this kind of 2D in 3D faked solution. Here, these are specific solution for 2D, 3D, really prepared to handle those different types of games and rendering. Scripts, where we're gonna write our scripts, and asset library. Well, we're not gonna use this pretty much. What is the most interesting for us is, of course, 2D and script. Here on the left, you have information and tools about running your project. So run project, here F5, that's gonna be most interesting, and then play current scene. Sorry. Here's the render that we've chosen. On your right, we're gonna find the inspector. So as we're starting to work with our scenes, which are game objects in Godot, here we're gonna see all of their properties that we can work with, change, and configure for our need. Here we're gonna see node setting, because basically everything in a Godot is a node, and here we'll have some settings about them. Here's the history of the commands run in the Godot. Here's our file system, which is the same as our set of files, basically, that we're using for our project. And here's our scene configuration or additional import that we need. Okay, so with that being said, I'm gonna check some settings that we'd like to have for our project. If we run it now, we don't have any scene, so let's actually create a scene, and I'm gonna make a 2D scene, and I'm gonna call this just game, or main is gonna be fine. As you can see, now we have the information about it being unsaved, so what I can do is just press Ctrl S and save it somewhere. So I'm going to create new folder to keep everything nice and tidy. And I'm gonna call this scenes. Okay, and here I'm gonna save it, and I can run it already. Select current. Well, one of your scenes, one of your game object, has to be designed as a main, as an entry point to your project. So you can do this in two ways. I can go here and click right, and here I can choose the option set as main scene, and that's going to designate this as an entry point for our project. If I'm going to run it, you can see there's, of course, nothing there. So one thing I would like to do for the start is I'm going to go to project settings, and I'm going to search the settings and find clear color. And here is the default background color. I'm going to turn it all black. So we have that set up. Next thing I'm going to do is I'm going to bring in some assets that we're going to use. So I prepared some very simple assets. Let's go here. Let's create new folder. I'm going to call this assets. Maybe make it big. Okay. So I have a sprite for a food, which is just a red rectangle. There I have a sprite for a snake, which is green rectangle, and then we're gonna have to have some walls. And for that, I have just top bottom wall. Okay, so nothing fancy here, just some PNGs. But as you can see already here, I have my first node, and here it is in 2D view. It has some location, and when I press on it, you can see that now I have the set of tools to use. Most important is move mode, which is under W, right? If I start to move it across, of course, what is changing is the position I'm gonna work with. So let me just reset that. And basically, what is cool about Godot is that, as I mentioned, everything is a scene, and you kind of build it like, for example, like Lego bricks or React components. Everything is trying to be independent and self-enclosing, and then you use those blocks to mash together a game. And I'm gonna tell you more about it, or show you how to do it right now. So we're gonna need another scene, and what we're going to use for that is we're gonna create our snake. So I'm gonna go to scene, new scene, or control sorry, control N. I'm gonna use 2D scene, and I'm gonna make the name to be snake. And for now, this doesn't do anything. So let's create new folder called snake. Save as snakes and scene there. So for now, if I run it, it doesn't, of course, show anything or do anything. But basically, this is good enough for us to start coding. So I'm gonna attach a new script to that, and we're of course using GDScript, right? Because we did not set up C# or C++, because those, from what I know, are two other possible languages to use in Godot. So let's create, and here we have our script default template in GDScript. So you can see that this is extending another class and has some functions. And if you take a closer look into the language itself, it works with indentation and is pretty similar to what Python is doing. So it's based off of Python, and if you know Python, you're gonna be right at home. If not, it's gonna be rather easy to grasp. So here we have some functions which are being called. This one is being called whenever the scene is loaded. So if you take a look at the description, everything we're gonna do here is gonna build a tree, and whenever a tree gets the scene added, this function is gonna get called. And then of course this is the process, which is like update, and is being called every frame. And of course we will have other stuff, like for example physics process, but we're not gonna work with physics in that game. One information about our wonderful language is that it is Python, but it can be optionally typed. So you can add some types here and there. For example, you can type this, inform our compiler that this is float, right? But it's optional. So what I do is I tend to type some stuff, but not everything, just enough to make it work. Okay, let's start coding then. First, as you can see, this is a class, but it's like not described and we don't know what it is. So I'm going to say that the class name of that is a snake. Okay, and we're gonna need some information here because we need to display our wonderful snake head. So I'm gonna take a reference to a texture of our snake body. So I'm gonna create a variable and call it body texture. And of course, if you don't know, variable is just like a place in memory to hold stuff. And if I like to sorry, load a snake art asset that I prepared, I can just point to the path of it. Okay, so we have that one done. And then I would like to create the head of my snake. So what I'm going to do is already I'm going to create a head, which is going to be a sprite 2D, and this is a node, and this is going to represent a sprite in our game. What we could do alternatively is to go here and we could go add child node and find a sprite here. So you can create the nodes which are parts of our scene via code, or we could use that create new node window to add something to our scene tree. Okay, I'm gonna do this by code because I'm gonna configure this a little bit from the start. So I'm gonna say that the head position, which is this transform position, right? I'm gonna reset this to vector2 0 0, and this vector is of course a representation of our position. So basically, when we're talking about vectors in game development, this is for xy for vector 2 or xyz for vector 3. And what is cool in Godot that as I said, there's a quite good separation between 2D and 3D, so you will never have that situation where you have cast vector 3 to vector 2 like you have to do in Unity. Okay, let's see. I'm gonna set a head scale to vector of 1 1, and I'm gonna say that the texture is our body texture. Okay, this is good enough, and that's not gonna change anything, as you might imagine, because we created the node, but we didn't add this to a tree. So under here, I'm gonna create new empty node, which is the node itself. It has like no graphical representation and basically no use, but can be used as a container for other nodes or for some script functionality. So basically it's like an empty object from Unity. And I'm gonna call this snake parts. And then I would like to get the reference to that node in my script. So to do that, I can say onReady, which is gonna be like get the reference during the runtime of that function, for snake parts, and this is a node. And here I could use $sign and then specify the name to get the reference to that snake. parts. Alternatively, what I could do is just say var snake parts get node, and here I could specify the path. So this line and this line are pretty much the same. Okay, but if you can get away with declaring the references to your nodes using the onReady declarator, I encourage you to do so. Okay, and now I'm just going to say snake parts add child to add this to our game tree head. Okay, let's see where this changes anything. Not yet, and this is because if we run our game, we can see what is in our currently running tree by going from local, which represents the node that we're currently working on, to remote to show you the whole tree of our game. And as you can see here, we don't have the instance of our snake scene here in our game scene. So what I can do is just close that. And here I'm going to go instantiate child scene or Ctrl+Shift+A. And I can find the snake here, right? And as you can see, now in our game, we have the instance of our snake. So let's try this again. And you can see that it has been added into our game, but it's in the 0, location in the upper left corner. Okay, cool. So how can we like set this to be in the middle? There are a few options. One, for now, you can see that what's going to be rendered is limited by this blue and purple and yellow line. This is our game bounding area, but we can add another child node and call this, and we were searching for camera, and we can click on it, and now you can see that there is something else shown here. We can see that the camera is now set here. It has the offset of 0, 0, so it's also in the middle right here. So now our snake is gonna render into the center of the camera, right? And let me find a zoom, and we're gonna change this to 0.5, and now you should be able to see that we scaled it up. So let's run this, and now we have our snake head in the middle, which is perfect. Okay, so with that setup, what we can do is we can now set up another thing that we need to add, and add our walls. So I'm gonna add a child node to our game. I'm gonna choose just an empty node because that's gonna be container for our walls. Call this walls, and I'm gonna add sprite2d here, and I'm gonna create some walls. So that's gonna be bottom wall. Then I can press Ctrl+D to duplicate that. I'm gonna call this top wall. Then I'm gonna duplicate that and call this right wall. Duplicate this and call this left wall. Okay, and we need to configure this a little bit. So let's click all of them, and then I can drag and drop Here you can see that as I'm dragging this texture empty is getting highlighted, so I can drop our wall texture there. And we need to configure it when it comes to positioning. So let's set this up properly so that it binds some area within our game. So the bottom wall, let's go to transform, and the position is going to be 480, and I'm also going to scale this to 199.933. And as you can tell, it scales up both horizontally and vertically, and we don't want that. So let's press Ctrl Z to undo that. I'm gonna click on this unlink properties, because currently if we're changing the X, the Y also is gonna change. I'm gonna click that, and I'm gonna write 933 here. Okay, this is perfect. Let's go to top wall, and the top wall, as you can imagine, gonna be similar. So let's go to -480, and unlink that 1.933, and unlink that. Try this again. This is not correct. This is oh, it's X. Okay, it's X. This is top wall. Let's go to the right wall and go to the right wall and go to transform. I'm gonna rotate that, of course, 90 degrees. I'm gonna move that to location of 896, and basically no need to scale this because it encloses our area. Same goes for the left wall. I'm gonna rotate this -90, and then I'm gonna set this to -896. And please make sure to input those number precisely, and it is important to do so because our snake has our snake head, the PNG itself, it has 32 by 32 dimensions. So we're gonna sorry, we're gonna move it like step by step. So the whole area enclosed by our walls has to be divisible by 32, because otherwise we could be in a situation when we're partially overlapping the wall, and we don't want that. Okay, so that's basically it. Yeah. Let's go to our snake and let's try and make it move. So to move it, we'll have to read the user input. So to do that properly, we will have to create an input map. So let's go to project settings, input map, and here we can add actions. So I'm going to name first up, down, right, and left. And here we can start adding key bindings. So I'm just going here by clicking plus. Then here we have information about listening for input. So anything that you will press is going to be recorded as an input for that action. So if I press W, here you can see that the W key has been added, then S, then the right is going to be D, and left is going to be an A. And this is pretty much it for all the input that we need for our snake game. Okay, so now the question is, how can we actually use that input in our script? Okay, so this is rather simple. I'm gonna create a move direction here variable, and it's gonna be vector2. It's gonna start as 0. So this is equivalent of I'm saying vector 2 0 0. So this is no movement at all. If we'd like to go so no movement, if we'd like to go up, that's gonna be 0 minus 1, because remember that this is the positive y-axis. So going up, we're gonna have negative y-axis. This is up, and for example, if we'd like to go right, it's gonna be 1 0. Thankfully, vector2 class has some simplifications here that can help you with those values. So the most common values are already prepared there for us. So with that explanation out of the way, let us write a function to actually calculate our move direction. So if you write an input function with an event, this is the special function that's going to be called whenever player provides some input. And we can try and calculate our move direction here. So if event is action pressed, we're gonna search for UI right, and this is going to be the right arrow, and we're also going to take into account our right action that we configured is action press right, and we have to check whether we're not moving left, because if our snake is going right, we cannot just turn left and crash into ourselves. Same if we're going up, we cannot go down, we have to go right or left, right? So let's say and in GScript we can write and, or we can write this, which is well known from other programming languages. X is not equal to -1. And we can get rid of the, let's just accent this, get rid of these. Oh, sorry, we have to have that in place. Okay, then column here, the move direction is going to be equal to vector2 right. Else if, which is elif into the script, we can basically copy all that and check for the UI left, and left, and here check for the 1. So this is the left movement, so the move direction is here. Move direction is gonna be vector2 left. Expected closing. Oh, maybe we need that actually. Okay, so let's add that and that. This isn't correct. Okay, then Let's do the same for up. And this is going to be move direction vector 2 up. And in the end, we have I think we're missing that here. Oh, we have moving XX. This is Y, of course. This is also Y, and here we're checking for UI down and down. And that's gonna give us move direction vector 2 down. Okay, let's see. Expected closing after grouping expression. Let's see. About that, about that, about that. And here we're missing the closing parenthesis. Okay, cool. So in the end, let's try saying what our direction is, and I'm going to just use print debug and display the move direction. So let's hit play. Let's see. Invalid type function is action press in base. And it seems that I screwed up the parentheses here, so that shouldn't be here. That shouldn't be here. That should be here. So it's correct. That should be here. That shouldn't be. That shouldn't be here. So always check your parentheses. And that should be correct. So let's run this. Okay, and as I'm pressing up, as I'm pressing left, right, and down, you can see that the direction is calculated properly. Cool. What about making our making our wonderful head move, right? So we could use function process to move it every frame, but to be honest, I don't want to perform a movement every frame with some kind of velocity or with transition. I would like our snake to move like the same amount after given break, right? So to do that, I could use a child node, which is very nice and called timer. I could listen to the timeout signal from it to move my snake. So let's configure this really quick. This is gonna be auto start, so it's gonna start automatically, and the wait time is gonna be bumped up to 0.2. And now to communicate between components, GScript uses this thing called signal, which is basically a glorified observer pattern. So this timer is gonna shoot the signal whenever this time runs out, and I can listen to it and do something then. So I'm gonna take a reference to that timer here. So on ready var timer, seems like a good name, timer. Okay, and what I can do on ready, I can just say set up the timer. I'm gonna say timer timeout, and take note of that icon here, right, which resembles Wi-Fi icon, saying that this is the signal to which I can connect. I'm gonna say connect, and I'm gonna create a function called onTimeout, which is not defined, and that's gonna trigger an error here. But let's create that function on timeout, and for now just print timeout, and let's see what happens. Okay, you can see every 0.2 seconds that's getting fired up. So this is very, very good. So basically what I want to do is to move. So let's see. I'm gonna create a simple function. Let's maybe I can write pass here just to suppress that function from throwing error. I'm gonna create a function called move to position, and I'm gonna pass new position here. And for now, I'm just gonna say position is equal to new position. We're gonna extend that function a little bit later, and for now, I'm gonna just say var new at position is equal to current position plus move direction. So how much do we move? I'm gonna create a const here, just body segment size, and I'm gonna say 32, because if we take a look at our PNG, that's the dimension. So move direction times body fragment size is the new head position, and then I'm just gonna call move to position, and that's gonna be new head position. And yeah, let's see where this works. Not really. So let's see what happens here. So to make it work, we will have to add another piece of code. So our snake is gonna build by the head and rest of its fragments, like a tail, and we'll have to keep track of position of each body fragment. So I'm gonna create an array body fragments, or body parts, actually will be a better name, and it's gonna be an array. And here, when we create the head, right, and the head is of course the sprite, we could also go and say body parts append, so add to this array the head, and then when we update position, we have to take the body parts and this is the reference to the first element in an array, so to the head, and set the position to new position. And with that, we have our wonderful snake moving. One problem though, as you can tell, is that we can go across the walls, which is not necessarily what I wanted. So let's fix that. To do so, first we have to have the information about our walls. So let's go to our walls container, and here I'm going to add a script. Walls. And I need to keep the track of where each wall is being placed. So here I'm gonna go and add a class name. I'm gonna call this walls, and I'm gonna create walls dictionary. And we're gonna do the collision detection by hand. It can be achieved also with use of area2d component, but we're gonna focus on that in the next tutorials. For now, let's just try and do this by hand. So what I'm going to do is I'm going to click on all of the walls inside of the wall containers. I'm going to go to node, and let's see, and I'm going to go and choose the groups. I'm going to add a group and call this walls. And what we are going to do is add each component to the same group. Also click manage groups and add the wall like that, but also writing the correct name is gonna work. So here I'm gonna just write get tree, which is going to get the whole tree of the game, and then get nodes and group walls, which is gonna give us back the array of those nodes. And then I'm gonna just do a simple iteration for wall in walls, so for loop, and I'm gonna add this to the dictionary. So let's say to have it properly typed, if I'm gonna write a wall, right, I don't have the information about position. This is because the compiler doesn't know what type this is, right? So I could say node to the thing, that's typing array, or node to the array, like that. Does this help? No, this isn't correct typing either. Array of node to be. How do you cast? Or let's do as node to the array. No. Let's try. Okay. Okay, so to type this property, I can write as array node to d. And now can do wall position dot x is less than 0, add this, let's say if wall position is x is less than 0, that's the left wall. So let's do left, and here I'm just adding stuff to an array. This is right. Let's check now for walls thick. Okay. Position y is less than 0. Wall sticked. Top of the wall. This is correct. Now if walls wall position y is greater than 0, wall sticked bottom equal to wall, oops, bottom is equal to wall. It's all correct. We're also gonna need two other pieces of information, and that's top left corner position, vector 2, and then var bottom right corner. And we're gonna assign this here. You can say top left corner with the vector 2. So tap left, so x is left, so wall ticked left position x. And here you can see that I don't get the autocomplete for position, right? Because we don't have the wall dictionary typed, but that's fine, we know what's inside. Top. This is for y, so position y. And then we have bottom right corner, which is vector 2, walls dict right, position x, and walls dict bottom position y. Okay, and we can get rid of that. So now we have every single piece of information regarding the walls in our script, and we can use this in our snake. Let me show you how. We'll need to get a reference to our walls here, and we can try and find that node by searching through the tree, right? Because here we have the snake and here we have walls. But we can also make that property available in our editor, in the editor UI, and just drag and drop it. This is like serialized header in a Unity. So I can just do export var walls, which is like walls, and this export decorator is going to help us, because now if I go to inspector in our game and take a look at the snake scene, now I can find that the walls are expected here, and here you can see that everything that is not of correct type is grayed out, and walls are available as a reference. So I can do that, and I can click here and clear this reference to show you that alternatively I could just drag and drop it. Okay, cool. Um, so yeah, um, let's see. We will now calculate our walls collision. And just to simplify what we're going to write here, I'm going to create another variable here. So this is stuff regarding walls. Here I'm going to write walls dictionary. Yeah, and for now it's going to be empty. And here I'm going to say walls dictionary is equal to walls dictionary, just to make my life a little bit easier. Okay, and now we can use that to detect our collision. So let's move to our on timeout, and here we just simply go for movement, but instead I'm gonna do var wall collision, and we're gonna write a function and say check wall collision new head position. So let's write that. And it's gonna be rather simple. Let's see. To manage that, actually, let's write this first. So function check wall collision. Let's take a new head position, which is vector 2. Now I'm just gonna write pass. Yeah, we're gonna create a simple enum. Could use basically vector 2 for that, but I'm gonna show you how to write an enum in GScript. So collision direction, and this is top, bottom, left, right. So this is good whenever you have some close set of values that you'd like to manage, like, I don't know, days of the week, or in our case, collision directions. But you could also do the same by just using vector to right, left, and so on and so forth. Sorry, bad cough. Okay. And now we'll write our function. So yeah, let's start checking for stuff. So if new head position x is equal to walls direction left position x and move direction is equal to vector 2 left, we can get rid of the parentheses in GScript. Then we crash into the left wall. Okay, and you can already tell where I'm going with this, right? So let me copy this and say, if that is right position X and the movement is right, we crashed into collision direction, right. Else, if we did Y and then top Y and move direction is up, then return collision direction up, and the same is gonna go for bottom. Y and down, of course. And that's gonna return collision direction bottom. Okay, so now we know about, couldn't find because this is okay. And now we know in which wall crash. So basically we're checking where our stake will be moving to and whether this is a position of a wall and if the direction to which we're going is, well, correct, right? So this is good, and now we have our wall collision. So let me debug this. And let's see. Invalid. Oh. Okay, cool. Let's try this again. Okay. And we're writing something in timeout. This we don't need anymore. It's gonna be null, 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 null until we hit the wall. I hope. Right, two again, and yeah, basically should be correct. Yeah, 0. Okay, fine. So we now have our wall collision direction. So now we have to decide what to do with it. If there is no wall collision, which is null, of course, then we can just move to position, right? Else we have to calculate the new position to which we should move. So let's say a position after wall collision, nice and descriptive, and I'm going to create a function called get position after wall collision, very nice name, pass the current wall collision, pass new head position. And we have to create that naturally. So func get position after wall collision, and head position. Let's call this new head position. And this is gonna be of type wall. Can I assign this collision direction? Sorry, collision direction, and this is vector 2. Okay, cool. So now let's calculate this. There's going to be a lot of ifs because we're doing the detection manually. If wall collision is equal to collision direction left, or wall collision is equal to collision direction right, so if we're moving, if we hit left or right wall, and new head position y is less or equal 0, so if we're in a upper right of the screen, so let me just show you how that should work. Okay, so if we're in the upper part of our bounding box and we hit that wall, we should go down. And if we hit the in the lower part, we should go up, because it only makes sense to go along the longer route. And if we hit the top or bottom and check for the X position, right, we should go left, or if we hit in the left part, we should go right. Okay, cool. So that's basically what we're writing here. So in that case, I'm going to just return move. We're gonna set move direction, and just do vector down. We're not gonna return this. We're gonna rewrite this. And I'm gonna show you why in a second. I'll see if let's this, and let's copy that. If it's bigger than 0, we're gonna set the move direction to up. And we have to assign the value to move direction here for it to be remembered on the next timeout call. So this has to be permanently written into that value to override what was passed by the user during the reading of the input. Okay, do the same for this is top and bottom. We're checking X here, and in that case the move direction is vector to right, and in the end we're gonna check for top, bottom, and check for X to be greater than 0, and in that case we're gonna move left. Vector to left. Cool. And now we need to say return body frag, body parts, sorry, 0 position plus new move direction times body segment size, right, which is like overriding the value of the head position. So we have that, and then we might say, instead of going here, in that case, if we have hit the wall, we have new position to move to, and that's going to be move to position position after wall collision. Let's see how this works. Cool. You can see that now our snake is gonna move along the wall properly, and what if it's going to hit the bottom? Well, it's gonna go unfortunately it's gonna keep moving down, and it is not working correctly because I've made a typo. It should be Y here, obviously. Let's try this again. So it goes along the okay. Now you can see that whatever happens, our wonderful snake is sliding correctly along the edges. So we have that sorted out. The next part that we need to add is a way for us to spawn some food. So let's create a food scene here. So go to scene, new scene. Basically we could get other node, and I'm gonna search for sprite 2D. I'm gonna call this food. I'm gonna save this. Maybe create new folder, call this food. And we need to assign the textures here, and as you can tell, this is going to be food texture, and we don't need any scripts here. Basically, this is all that we need. So now we need another node here that's gonna have a functionality of a food spawner. So we're gonna add some script that's gonna match where our food is getting spawned. So I'm just gonna choose node, call this food spawner. We can save this in the food because these two are closely related. What I'm going to do is I'm going to add this to group. I'm going to call this food spawner because it's going to make it easier to find the tree. And I'm going to add script here. And we can start coding. Let's name this. So class name, it's food spawner. Let's put this up. And we don't need to process. We need to have some references here. So we need our first reference to our walls. So, and we're gonna need a reference to our food scene. And it's going to be of type packed scene. What else? We will need the information about food position. It's going to be vector2. And of course the size of the segment. So body segment size 42. Sorry. And on ready, we're gonna just spawn food, and we're gonna create a function for this because we'll also need to call this again whenever our snake eats the food. So spawn food. We will need to have the reference. Okay, we're also gonna have to have a reference to instantiated scene. So we're gonna keep this in a food variable. Okay, say food scene instantiate, which is gonna dynamically create the instance of the. Basically, it's gonna create a node from a scene, right? So this is like instantiate in Unity, and then we will have to find X position and Y position, and it has to be spawn inside of our walls, right? So we can say random int in range walls top left corner X and walls. Oh, sorry, this should be called walls. Bottom right corner X divided by body segment size times body segment size. So basically what this is going to create is going to find a random X position across the our bounding box, but like every 42 pixels, right? So it's gonna align perfectly with our snake, right? Because we don't want our food and our snake to overlap partially, so we can spawn it in 32, 42, 32, 42, 64, 64, 32, 64, 256, 42, and so forth and so on. So we have to work in 32 increments. So this is going to say get random values 32 increments. Okay, cool. Same is gonna go for Y position. Rand in range. Top left corner Y. Bottom right corner Y divided by body divided by body segment size times body segment size, and we're gonna add a child. It's gonna be food, and we have to set the position, and this is going to remember the food position to be vector 2 x position y position, and set the position of the food to food position. Yeah, I could say that this is gonna be sprite 2D. Okay. Yeah. So now that we have that, we can go back to our game and we can instantiate child node, instantiate food spawner, and see where that works. And oh, it's not going to work because go here, we have some stuff that we have to reference. So put the SCN, that's gonna be sim, and then a reference to the walls gonna go here. And yeah, we have our food, and if I'm gonna restart the game, you can see that it is being spawned, and if I try to get to it, you will see that they should overlap perfectly, which is what we wanted. Okay, so basically what we have to do now is to write a code for whenever our snake is overlapping our food. So let's do this. Let's see what we're going to need to have here. We're gonna have to have the reference to our food spawner, and we could use get node or we could try and find it using the $sign, but since we added it to a group, it's going to be easier to use that. So food spawner, already get the reference by saying food spawner is equal to get free get result in a group, and this is a food spawner. Okay, cool. So we have reference to that. And then on our timeout, here we're checking for wall collision, and here we're going to check for the food collision. Food collision. Okay, so let's see. if let's see, we're going to say here get position after wall collision, move to position. So basically this is also our new head position, so I'm gonna refer here to that. Let's see where this works. Yeah, okay, so now I can just say if new head position is equal to food spawner food position. So food spawner, we have to destroy our food. So let's write a function here, function destroy food. And this is rather simple. In Unity we'd use destroy, but here we have food QE3, and you can control press it, or you can how do you do this? Lookup symbol? No. You have online docs here, and we have search help, and we have QE3, and you have the documentation built into engine, which is really cool. Queues, they are not for duration of the current frame. Which is like a delete, which is perfect. So in our food spawner, we have that function now, so we can call this. We can call just destroy food. Oh, I don't think we have a type here, so let's fix this by typing it as with S, so we can cast it. We can just destroy food. We have that function now, and we have to spawn new food. So spawn food, and yeah, we now have to add new body segment to our snake. So let's see whether eating the food works for now. That is correct. So now we have to grow our snake. So let's say add body part, and we're gonna write that function. Go to the bottom here, add body part. Okay, we're gonna create a new segment here, or new part. It's gonna be sprite 2D, new part texture. We're gonna set to body texture. We're gonna change the scale so that our body is different than our head. So new part, scale is going to be, say, 0.9.9. Let's say what we want to do, body parts, append new part, and also we have to add this to the snake parts, right? So it moves in uniform with the rest of our snake body. So yeah, snake parts at child new part, and also we have to set its position, right? So let's see, if we're going down and we are eating our wonderful food, we have to add the body part behind, right? Because we're going down. If we're going from the left, we have to add it here. As you can see, it's being added, but it's not moving. So let's set the starting position. So it's going to be new part. Position is equal to body parts -1 position minus move direction times body segment size. Okay, and it should be spawning in the right position right now. Okay, cool. The problem is, as you can see right now, it's not really moving along with us. So that's the problem. Okay, so let's try and fix this. And to fix this, we have to go to our move to position and check where we have more body parts. So let's check the size. Is it bigger than 1? It is. Find the last element, and we'll say body fragments, body parts. Pop back to get the last element. Say last element position is now equal to body parts 0 position, and body parts insert 1 last element. So what we are doing here is, instead of moving the whole array, we're just moving the last part here. So let me maybe try and show this to you with my wonderful graphical skills. So we have the head, and it moves so that the body parts are behind it, and it creates the gap, right? So what we're doing is we're taking that last element and just popping it to index 1, because the head is at index 0 and we have the gap at the index 1 of our array. So instead of moving every single part, which is, we could do that, but it's not really efficient, we're just moving the last fragment, and we have that a notion of correct movement, but it's basically the imitation, because we're changing the position and the place of in the array only of the last element. And these are my wonderful artistic skills. Okay, let's see whether this works. Or are we missing something? No, it works perfectly. So as you can see now, we have yeah, we have pretty much working game, but there are some other things that I would like to add. Because for now, there is no way for us to lose the game. And we should lose whenever we hit ourselves, right? So let's add that. And we have moved to position, we have foot collision that we're checking, and let's add check for snake collision. I'm gonna say snake collision, check snake collision. Okay, and we can add that here. It's gonna be rather simple. So we have to take all the head cannot collide with itself. So we could basically take all the fragments without the body, without the head, sorry. Body parts without head is equal to body parts slice body parts size. Okay, so we're creating a new array without the head, and here you can say body part without head filter, and here we can pass another function. So this is like the basics of sorry, of the functional programming. So what filter does, we can just pass a function here, right, and make it anonymous and check which parts of the array with which entries in the array are going through that filter. For example, here we should return the stuff that it's not 1, so it prints 2, 3 because 1 does not go through that filter because of that logic. So I can go here and say function part return whether the given part position is equal to my current position. Okay, so what we're checking is this position is basically the head position. So we're checking if any other part has its position set to the position of our head. And now that I think of it, we should basically pass new head position here and use that instead. That's gonna be correct. So here we can do new head position. Okay, and if that's correct, if we're crashing to our bodies, return true, otherwise return false. So now I can check where we have a collision here. What we should do, we should basically stop the timer. That's gonna stop our movement. Okay, let's try and crash into ourselves. Okay, yeah, I was able to do that, and as you can see, it stopped the movement in my game. Cool, this is very good, but what we're missing here is any kind of basically you could call it done, but what I'm going to do is I'm going to add a very simple UI for our game. So to do that, I'm going to go to game, add child node. Let's search for canvas layer. I'm going to call this UI layer. And what I'm going to do is basically save this as a new scene. So save branch as a scene. I'm going to go to scenes and I'm going to save this as UI layer, and then I'm going to click here to open this as a scene. Sorry for all the coughing, I'm still a little bit sick. Okay, and let's see what I would like to achieve in here. Some simple UI. So I'm gonna add I'm gonna add a box container. Okay. I'm gonna add two buttons here. It's gonna be restart. I'm gonna search for button, and I'm gonna search for another button to, or I can duplicate it. So that's gonna be restart, and that's gonna be quit, to show you how to quit the game. And then I'm gonna also add label and another label. So that's going to be points label. It's gonna be game over label. Okay, cool. And of course, we're gonna need to attach a script. Wonderful. So first things first, I'm gonna get some references to my stuff. So yeah, we don't need the process. So for example, I would like to get the reference to my restart button. And I could do that by using the $$ operator and saying this is living in the under box container and then restart. This is correct. But if I don't want to go through this extra layer in my tree, I could go to scene and here I can choose access as unique name. And you're gonna see that the percent sign is next to my node. So I can get rid of that and just say $% restart. The same for the quit button. I can just go this. Okay, then already say game over label is going to be game over label. Then points label is going to be points label. Perfect. And I will also need a reference to my button container, and I could like do that the same, but just for a reminder, I can also do and I think that this should be different type, so I can just click right and choose change type hbox container. Cool. Hbox because I want to have them in a horizontal line, and I can do button container is equal to get node box container. So remember that there's always alternative when it comes to getting references to your nodes. Okay, let's set this up properly. So first I'm going to say restart, and then I'm going to say quit. About positioning, I would like to position this in the middle, so I have that. Also, I would like to change the width, so width, where is it? Here I can change the width, alignment center, and it's not called width but just to confuse you a little bit, it's called custom minimal size. So I'm gonna say 400. Okay. And then here, custom minimum size for these. Let's say 100 pixels. That one, 100 pixels. Okay. Let's see. Can I change the alignment here? Not really. Probably what I'm gonna need to change is gap, and there's a separation property in team overrides. Let's try something like 32. Okay, then anchor doesn't really change anything. Okay, now let's go to our points label. So say points to 0, and I'm gonna move this here and not in the middle, but here. Maybe move this a little bit, and then for game over, that's gonna be rather easy because I'm just gonna write game over, go to theme overrides, go to font sizes, the font size is something big, 100, put this in the middle and change the font color to red. Cool, and basically that's all we need to do here when it comes to setting the simple UI. And I don't want to have those buttons visible from the start, so I'm gonna hide this by clicking toggle visibility, and also toggle visibility of the game over label. Okay, and going back to our script, we need a few simple functions here. So yeah, let's say what should happen on game over. We should set our button container visible to true. We should also set our game over label to visible and true. Now we should set up our button presses, right? So let's make them visible from the start. And how could you do that is you could go to raster button, pressed, and you can see this is a signal. So we could just do connect and connect it to a function. That's one possibility, which is correct and done from code. The other is to click on the raster button, go to node and signals, and here you can see that you can just right click on pressed signal and create a function right here. And here you will see a symbol that this is connected to a source, which is a button. Both versions are correct. So let's do this one with the UI connection, and we're gonna go and call reload current scene. Just gonna restart everything, and then for example, to connect from the code to a button press, I'm gonna go pressed connect and say on quit button pressed, create that function on quit button pressed, I'm going to say get 3 quit. Okay. Yeah, let's see where this works. So I'm moving now, and if I press restart, as you can see, everything is restarted. And if I press quit, it closes. Perfect. So let's hide this again. Now, the last thing that we have to do sorry, is to be informed whether when our points are scored. So I'm going to say on point scored, what should happen then? We should get information about new points, and we should update the points label. So points label text is equal to points %d %points. And this is the string formatting in GDScript, right? You can read more about it in documentation, but basically it's gonna take the %d here and replace it with points value. Okay, cool. And now what we have to do is actually inform our UI when the game is over, so when the snake eats itself, and we have to inform about scoring points. So we need to go to our snake and actually declare that it's gonna emit some signals. So for now we only work with the signals emitted from the stuff like UI or timer, which is already built in, but we can build our own signals to inform our game about events happening in our game. One of these events is us scoring a point, so eating the food, or crashing into ourselves. So what we can do now is just create those, and it's really, really easy. Just say signal on point scored, and this should have points assigned as an argument, and then another signal which is on game over, and since it's not going to take any arguments, we can declare it like this. And we also need points to track, and we start at 0. Cool. So let's go on timeout. This is our collision, and we can say, well, this is game over, so emit that signal. And then we can go here, and well, we've eaten our food, so we should increase our points by 1, and on point scored, emit that with points as an argument. So this is how you can create and emit your signals without arguments or with some arguments. And now the last thing we have to do is go to our UI and reference the snake, right? And there are a few ways to do that. We could add a snake to a group and find it from group, or just get this node from the tree. So let's try first that way. So if you take a look at our game tree, our UI layer is a sibling when it comes to nesting to our snake. So if I would like to get the reference to that, I could say go up 1 level, and so now we're like on the game level, and then take the snake from that. Okay. Oh, and that should be, of course, on ready, right? And I can say that this is basically snake. Okay, and then on ready, let's say snake On game over, this is a signal, so connect on game over, and remember to pass a reference and not call a function, and then snake on point scored connect on point score. Again, a reference. And let's see where that's gonna crash and burn. It will. Invalid on base node to the snake. That's because why? Snake is an object, and it looks like it should be working. Let's see, on game over signal. Invalid get index on game over. Make to D. And this is of course me making stupid typos. On game over. Okay, let's see. First, let's see whether the points update correctly, and it seems like they will. This has been going for almost 2 hours, so we're gonna test that in end. But one thing you could do is increase the snake speed every time you eat some food, and I'm gonna leave to you to figure out how to do that. Let's eat that last bit of food. Okay, game over, restart, quit. Yes, this works correctly. Yeah, basically, that's how you can write a snake. Oh, the food is spawning inside of the walls. So it means that we have a bug there. Let's see. Let's go to our food spawner. Oh, I know what this is, or at least I think that I know. Top left corner X. So top left corner X plus body segment size. Do not spawn into a wall, and then right minus body segment size. And then top left, so this is top, so we have to add body segment size, and then minus body segment size, and we should be good now. So yeah, this is basically how you could write a snag in Godot script and in Godot 4. So yeah, let me know what you think about it and whether you'd like to see more of it. Again, I find that engine to be better for my needs than Unity. Everything is self-enclosing scene. Everything is independent. It's easier to compose. You don't have to worry about managing prefabs. The UI is more modern. I know it's not yet as developed as Unity, but I really believe in it, and I believe that it's got a bright future ahead of it. So probably from now I'm gonna stick to it in my game development endeavors. So let me know what you think, and comment, like, hey, maybe subscribe. So thank you, sorry for coughing, and I'm gonna see you in the next one. Goodbye.